Some breaking news now. There have been two small earthquakes, and they've rattled parts of Northern California this morning.
Within just 72 hours, the San Francisco Bay Area has experienced two magnitude 3.7 earthquakes, the latest near Pleasant Hill at a depth of 7 miles.
Magnitude 4.5 quake struck near Pleasant Hill.
9 earthquakes in just 4 days are shaking the very ground where the devastating 1906 San Francisco earthquake once tore through. Could this be a sign that the fault is awakening again? Is this swarm a precursor to another disaster of epic proportions? What's triggering this unusual seismic activity, and how concerned should we be about what's next? Join us as we explore the latest USGS reports, uncover the science behind these quakes, and examine the unsettling parallels to one of history's deadliest earthquakes. You won't want to miss what we've discovered, as it could impact millions in the Bay Area and beyond. A series of tremors has disturbed the San Francisco Bay Area over the past few days, catching the attention of both scientists and residents. In just 4 days, 9 earthquakes have been recorded near the San Francisco Zoo, with magnitudes ranging from a barely noticeable 1.0 to a more significant 2.4. While these may seem minor, they're clustering along the infamous San Andreas Fault, the same fault responsible for the catastrophic 1906 earthquake. Raises important questions. Are these small quakes merely the Earth's way of adjusting, or do they signal something much more significant? This ongoing activity heightens concern, reminding us that California's tectonic foundations remain as restless as ever. The first quake in the swarm struck on January 14th, 2025, with a magnitude of 2.4 at a depth of 9.4 kilometers. Within hours, 2 more quakes followed, a magnitude 2.2 and a magnitude 1.8, each occurring just a few kilometers from the initial event. The swarm continued over the next few days, with the largest quake, another magnitude 2.2, hitting on January 15th. By January 18th, the smallest quake in the swarm, a magnitude 1.0, occurred just 4 kilometers west-southwest of the San Francisco Zoo at a depth of 7.2 kilometers. These depths indicate that the quakes originated within the Earth's brittle crust, where tectonic stress often accumulates. An earthquake swarm, characterized by multiple quakes of similar magnitude in a short period and confined area, can have various causes. Unlike a typical main shock-aftershock sequence, swarms suggest localized shifts or disturbances within the crust, with implications that can range widely. One possibility is that these quakes result from stress redistribution along the San Andreas Fault system. Tectonic plates, such as the Pacific Plate and the North American Plate, are in constant motion, grinding against each other at a few centimeters per year. Over time, this movement builds immense pressure along fault line. When this pressure becomes too great, the crust fractures, causing earthquakes. Swarms like the current one near the San Francisco Zoo may indicate the fault releasing small amounts of accumulated stress. However, the proximity of these quakes to the fault surface and their frequency suggests that something more dynamic might be occurring. Another potential trigger could be fluid migration deep within the Earth. Seismic swarms are sometimes associated with the movement of water or gas through cracks in the crust, increasing pressure on existing faults and causing them to slip. This phenomenon is often seen in volcanic regions where magma intrusions drive earthquake swarm, but it's not limited to such areas. Could a similar process be happening beneath San Francisco? While there's no evidence of volcanic activity in this region, the possibility of fluid-induced stress changes in the fault zone cannot be dismissed. It's also possible that this swarm is a localized response to distant seismic events. Significant earthquakes elsewhere in the world can cause subtle shifts in stress along distant faults, sometimes resulting in swarms. This is known as dynamic triggering, highlighting the interconnected nature of Earth's tectonic system. Whether these recent tremors are influenced by global seismicity remains an open question that scientists are actively investigating. What makes this swarm particularly concerning is its location. The San Andreas Fault is one of the most dangerous tectonic boundaries in the world. 1906. A rupture along this fault triggered a magnitude 7.9 earthquake that devastated San Francisco, ignited fires that raged for days, and claimed over 3,000 lives. The fault's northern segment, where the current swarm is occurring, has been relatively quiet in recent years, but history shows that long periods of inactivity can precede catastrophic events. Could these small quakes be a warning sign of a larger rupture, or are they simply part of the region's natural seismic rhythm, releasing stress in manageable doses? The truth is, no one can say for certain. Earthquake science has advanced significantly, but predicting the exact time and location of a major quake remains beyond our capabilities. What we do know is that the San Andreas Fault has the potential to produce earthquakes much larger than those in this swarm. The so-called Big One, a hypothetical magnitude 7.8 event along the fault's southern section, has long been a focus of seismic preparedness efforts. While the recent activity is occurring further north, it serves as a stark reminder of the power and unpredictability of the forces beneath our feet. As scientists continue to monitor the swarm, residents of the Bay Area are left to ponder, is this a fleeting tremor in the Earth's restless cycle, or the first signs of something far more ominous? For now, the best course of action is preparation, reviewing emergency plans, securing homes against potential shaking, and staying informed. In California, the question has never been if the next big earthquake will strike, but when. Revisiting the great 1906 San Francisco earthquake. The earthquake that struck California on April 18, 1906, remains one of the most significant seismic events in history, not only for its devastating impact, but also for the groundbreaking scientific discoveries it inspired. Spanning 296 miles, 477 kilometers, of the San Andreas Fault from northwest of San Juan Bautista to the tectonic convergence at Cape Mendocino, the event challenged the geological understanding of its time. Its vast horizontal displacement and extended rupture length baffled contemporary scientists, with the full implications only becoming clear decades later. Through the advent of plate tectonic theory, the earthquake's analysis paved the way for transformative insights into seismic activity, including the development of the elastic rebound theory by geologist Harry Fielding Reid in 1850-1910. This theory explains how accumulated strain in the Earth's crust is suddenly released during an earthquake and became the cornerstone of modern understanding of the earthquake cycle. At approximately 5:12 a.m. local time, a foreshock was felt across the San Francisco Bay Area, serving as a brief prelude to the main event, which began 20 to 25 seconds later. The earthquake's epicenter was near San Francisco, and the violent shaking lasted an estimated 45 to 60 seconds. The tremors were felt as far north as southern Oregon, as far south as Los Angeles, and as far inland as central Nevada. The modified Mercalli Intensity (MMI) scale recorded values of 7 to 9 along the fault rupture, with shaking extending up to 80 kilometers inland. A key observation from the 1906 Lawson Report revealed that the intensity of shaking closely correlated with local geological condition. Areas built on soft, sediment-filled valleys experienced significantly stronger shaking compared to those on stable bedrock. The most catastrophic impacts occurred in regions where reclaimed land along the San Francisco Bay liquefied during the earthquake, amplifying the destruction. These findings laid the groundwork for modern seismic zonation, which now accounts for variations in ground stability when assessing earthquake hazard. This event was not only a turning point in scientific research, but also a harrowing reminder of nature's power and unpredictability. While its devastating effects reshaped California's physical and social landscape, the earthquake's lasting legacy lies in the profound advancements it spurred in the study of seismic phenomena, ensuring better preparedness for future events. Global earthquake activity, a mixed bag. Let's examine the latest earthquake activity around the globe. Recent seismic events highlight a magnitude 3.2 earthquake near Ridgecrest, where a noticeable increase in seismic swarming has been observed along the broader west coast. Elevated earthquake activity has been recorded within the past 24 hours, including several events surpassing the magnitude 2.5 threshold. Since midnight, at least 6 earthquakes have occurred, ranging from magnitudes 2.8 to 3.0, distributed across various fault systems in the western San Joaquin Valley. A magnitude 2.8 earthquake was detected, while a cluster of smaller tremor was reported south of the U.S.-Mexico border. Further north, significant seismic activity has concentrated near the northern plate boundary, specifically at the southern end of the Cascadia subduction zone, a known hotspot for tectonic stress. This region has experienced heightened activity today, prompting scientists to closely monitor developments. Recent tremor data from Cascadia reveal a substantial number of deep tremor concentrated beneath Oregon, specifically near Salem and Portland, occurring at depths of 35 to 45 kilometers beneath the Earth's surface. However, no immediate earthquake activity has followed these tremors. While the situation warrants continued observation, the southern end of the Cascadia subduction zone, in particular, has shown elevated movement, a trend that could indicate building stress in the region. Meanwhile, Northern California's Bay Area has experienced a handful of smaller earthquakes along the Calaveras Fault, but no significant seismic events have occurred recently. In contrast, the Ridgecrest area in Southern California remains notably active, with numerous earthquakes distributed across various fault systems, reflecting the region's ongoing tectonic volatility. Although no major earthquakes have been reported lately, a noticeable increase in smaller seismic events has been observed, highlighting the need for vigilance, especially along critical fault lines like the San Andreas and San Jacinto faults. Geologists acknowledge the possibility of a significant rupture in the future, keeping this area under close scrutiny. At Yellowstone National Park, activity remains quiet for now. Seismograph data and recent earthquake maps show no significant seismic events in the region, and the supervolcano appears calm at the moment. However, its history of unpredictability necessitates ongoing monitoring. In Texas, the oil fields continue to experience minor seismic activity, a pattern often linked to human activities like hydraulic fracturing. Globally, seismic activity has drawn attention to several key regions. A magnitude 5.0 earthquake struck near the North Island of New Zealand, close to the southern end of the Kermadec Trench, within the last hour. Further south, the South Island reported a magnitude 3.4 event earlier today. Although localized activity around New Zealand has been moderate, the region's position along the Pacific Ring of Fire underscores its susceptibility to larger seismic events. The Java Trench near Indonesia has seen significant activity, with earthquakes migrating northward toward the Andaman Sea, including a magnitude 4.9 event off the coast of Sumatra, an area known for powerful quakes. This northward movement suggests stress transfer along the plate boundary, potentially impacting adjacent segments. The region's history of major seismic and tsunami events underscores the importance of monitoring such activity. In Japan, no recent major seismic events have been noted, though some older quakes are still recorded in the region's seismic archives. While the area remains relatively quiet for now, its complex tectonic setting demands constant vigilance. The morning saw 2 earthquakes, with one occurring the previous night, but no other significant seismic events were reported around the Nankai Trough. Although the situation remains calm, there's a sense of anticipation as all eyes watch for any signs of change. Seismic activity in Alaska has been relatively subdued, with a few minor earthquakes recorded in the past 24 hours. Most of the activity occurred late last night and early this morning, but throughout the day, only small tremors have been detected, many ranging from magnitudes 2 to 4. In Hawaii, the Big Island remains quiet in terms of large seismic events. However, the summit of Kilauea volcano continues to experience volcanic activity, with lava fountains visible in 2 distinct areas across the crater wall. The eruption appear stable, and the crater floor remains brightly illuminated as lava continues to flow. Volcanic activity like this is not uncommon on Kilauea, known for its prolonged eruptions that can last for days or even weeks. While the volcanic activity hasn't shown signs of escalating, the steady decline in lava flow indicates that the magma reservoir below is slowly depleting. Nonetheless, ongoing monitoring remains crucial. Around the world, seismic activity has been mixed. The Solomon Islands experienced a cluster of moderate earthquakes, while the Mediterranean region saw a series of small tremors. The Ethiopia Rift Valley remains quiet, as does the Atlantic Ocean, where no significant activity has been recorded. However, the Kermadec Islands region has been more active, with a magnitude 5.0 earthquake reported in the past hour. Solar activity and its impact. The sun is currently exhibiting heightened flare activity, with an estimated 3% chance of an X-class flare and a 70% chance of a flare event in the coming days. A new sunspot, designated 3964, has emerged unexpectedly, undergoing periods of rapid growth and complexity before slightly diminishing at times. The sunspot's current configuration, marked by distinct intermixing of magnetic polarities, suggests a potential for more intense flare activity, possibly reaching X-class level. Despite this, the area is not yet a major concern, as the core remains fairly separated from other sunspot regions, making significant flare activity unlikely in the immediate future. The primary region of interest is Sunspot 3964, responsible for a number of smaller flare events in the past 24 hours. This sunspot is large and active, with around 10 flares recorded recently. While these flares are substantial, no significant coronal mass ejections, CMEs, have been detected, and it's unlikely that the flaring activity will impact the Earth's aurora forecast at present. The situation remains calm, with no major solar outbursts predicted. Nonetheless, continued monitoring of this sunspot is crucial, as solar activity can shift rapidly and unpredictably. California wildfire progress and precaution. In Southern California, fire conditions remain active, but significant progress has been made in containing several blazes that have threatened both natural landscapes and residential areas. The Palisades fire, currently 39% contained, has scorched approximately 23,000 acres of rugged terrain in Chaparral. Originating in the Santa Monica Mountains, this wildfire has been fueled by strong Santa Ana winds, which have historically exacerbated fire spread in the region. Firefighters have deployed aerial resources, including helicopters and fixed-wing aircraft, to drop water and fire retardants, effectively slowing the fire's advance. Additionally, ground crews have established multiple fire breaks and have been conducting controlled burns to eliminate available fuel sources. While the Palisades fire hasn't advanced significantly in recent days, the absence of new hotspots suggests that containment strategies are proving effective. Continuous monitoring using satellite imagery and drone surveillance ensures that any unexpected flare-ups are promptly addressed. Similarly, the Eaton fire, which has burned 14,000 acres, is nearing extinction, with containment efforts now at 65%. This fire, which ignited in the Angeles National Forest, posed a substantial threat to nearby communities and critical infrastructure. The deployment of mutual aid teams from neighboring counties has been instrumental in accelerating containment efforts. Advanced weather forecasting has played a crucial role in predicting wind patterns and adjusting firefighting tactics accordingly. The reduction in active fire fronts and the stabilization of the fire perimeter indicate that the Eaton fire is on a downward trajectory. No new hotspots have been reported from either the Palisades or Eaton fires in the past few days, signaling positive developments and a potential shift towards full containment in the coming weeks. However, a fire at a lithium power plant in Monterey County remains a concern. The Vistra power plant, located in Moss Landing, experienced a significant blaze that threatened critical energy infrastructure. Although the fire has been active in recent days, the Monterey County Sheriff's Office has lifted all evacuation orders for the Moss Landing area, providing some relief to residents and workers in the vicinity. The incident has highlighted the vulnerabilities of industrial sites to wildfire threats, prompting a reevaluation of fire prevention and response strategies at such facilities. Firefighters have employed specialized techniques to protect sensitive equipment and prevent the fire from spreading to adjacent areas. Continuous air quality monitoring is in place to assess the impact of the blaze on local communities and the environment. Despite ongoing challenges in Southern California, further north in the state, there are no significant wildfires reported. Instead, authorities are managing a few prescribed fires aimed at reducing fuel loads and preventing larger, uncontrolled wildfires in the future. These controlled burns are carefully planned and executed under favorable weather conditions to ensure they do not escalate. In the Feather Falls area, a small fire was successfully contained and is no longer advancing as the day draws to a close. The proactive management of these prescribed fires is a testament to the region's commitment to mitigating wildfire risks through strategic planning and community engagement. The overall improvement in wildfire containment across Southern California can be attributed to enhanced coordination between local fire departments, state agencies, and federal resources. Investment in firefighting technology, such as improved communication system and advanced fire modeling software, has significantly boosted response efficiency. Public education campaigns continue to emphasize the importance of fire safety measures, including creating defensible spaces around homes and adhering to burn bans during high-risk periods. As the region navigates the ongoing wildfire season, the collaborative efforts of all stakeholders remain crucial in safeguarding lives, property, and the environment from the devastating impacts of wildfires. Seismic activity in Northern California. Attention is also turning to seismic activity in Northern California. Recent patterns suggest that the region remains seismically active, with intriguing developments over the last couple of months. Earthquakes in the Blanco Fracture Zone and Gorda Ridges indicate increasing stress and strain in the area, particularly along the southern portion of the Cascadia subduction zone. This deep, ongoing activity points to rising pressure within this critical fault zone, warranting close monitoring in the coming days. Over the past 6 months, Northern California has experienced a series of moderate to strong earthquakes that have heightened concerns among geologists and local authorities. The Blanco Fracture Zone, located off the coast of Oregon and extending into Northern California waters, has shown unusual seismic activity. Specifically, a cluster of magnitude 4.5, 5.2 earthquakes has been recorded, suggesting that the tectonic plates in this region are interacting more intensely than previously observed. These quakes, while not immediately destructive, serve as indicators of the underlying stress accumulating along the fault line. Similarly, the Gorda Ridges, part of the larger Gorda Plate system, have exhibited increased seismicity. The ridges are a significant site of tectonic movement where the Pacific Plate subducts beneath the North American Plate. Recent seismic events here, including several deep-focus earthquakes exceeding magnitude 5.0, highlight the complex dynamics at play. This heightened activity may precede larger seismic events, making it imperative for seismologists to enhance their monitoring efforts. The southern portion of the Cascadia subduction zone remains a focal point of concern. This zone, stretching from Northern California to British Columbia, is one of the most powerful earthquake-generating regions in the world. The subduction process here involves the Pacific Plate being forced beneath the North American Plate, a mechanism that can lead to massive earthquakes and subsequent tsunami. Recent data indicates that the locking depth of the fault has increased, suggesting that more stress is being stored and could potentially be released in a significant seismic event. In response to these developments, state and federal agencies have ramped up their seismic monitoring infrastructure. Enhanced networks of seismographs and ocean bottom sensors are being deployed to provide real-time data on tectonic movements. Additionally, emergency preparedness initiatives are being intensified, with communities being educated on earthquake-resistant construction practices and evacuation protocols. The economic implications of sustained seismic activity are also being closely examined. Infrastructure, such as bridges, highways, and utility systems in Northern California, may require upgrades to withstand potential earthquakes. Insurance industries are reassessing risk models to better account for the increased likelihood of significant seismic events in the region. In conclusion, the recent seismic activity in Northern California, particularly within the Blanco Fracture Zone, Gorda Ridges, and the Southern Cascadia Subduction Zone, underscores the importance of vigilant monitoring and proactive preparedness. As the region continues to exhibit signs of heightened tectonic stress, collaborative efforts between scientists, government agencies, and local communities will be essential in mitigating risks and ensuring public safety. Conclusion: the earthquake swarm currently striking the San Francisco Bay Area serves as a potent reminder of the region's seismic volatility. While the immediate quakes may be minor, their clustering along the San Andreas Fault, home to one of the most dangerous fault lines in the world, raises concerns about the potential for larger seismic events. Coupled with global seismic activity and ongoing volcanic and wildfire challenges, the Bay Area remains a focal point for geological monitoring and preparedness. As scientists continue to investigate the causes and implications of the current swarm, residents are urged to stay informed and prepared. Reviewing emergency plans, securing homes, and staying updated with the latest seismic reports are essential steps in mitigating the risks posed by California's restless tectonic landscape in a region where the next big earthquake is not a question of if, but when. Vigilance and preparedness remain paramount. Thank you for watching. Don't forget to like, subscribe, and hit the bell for updates on all things seismic. Until next time, stay safe.